Hi everyone, welcome to this new video lecture of fluid mechanics. In this lecture, we will discuss some problem related to simple U-tube manometer. In the previous lecture, we have discussed the theory part of U-tube manometer and piezometer. So in this lecture, we will discuss some problem related to the simple U-tube manometer. Okay. So the question here given, the right limb of a simple U-tube manometer containing mercury is open to the atmosphere. It is given clear in the question, while the left limb is connected to the pipe. Okay, so right limb and left limb. So two things are there. So let's draw the diagram for this. Let this is a pipe is there, and as this is a U-tube manometer, so let me draw this U shape is there, and yeah, and this is the pipe. Let's draw another one layer of this. Yeah, and inside this we have liquid is there. Okay, the liquid is flowing inside this, and this will be give a impact on the mercury which is present inside the pipe. Okay, and mercury is content open to the atmosphere, so that means mercury is present here. Okay, we'll give different color this. So let's give this kind of color here for the mercury which is open to the atmosphere. Okay, or you can dark it also. There is no problem on this. Okay, yeah, like this you can keep it. Now the fluid which is specific gravity is flowing, that is 0.9. So specific gravity which is flowing inside the pipe, that is 0.9. So this is light liquid, you can say. And the center of the pipe is 12 centimeter below the level of mercury in the right limb. Suppose this is the level of mercury. Okay, from here, how much distance of the center? This is the center of the pipe, suppose, and from here to here, the distance is 12 centimeter. Okay, this is 12 centimeter given. Below the 12 centimeter below the level of mercury in the right limb. Okay, find the pressure of the fluid in the pipe. So we need to find out the pressure in the fluid which is present in the pipe if the difference of mercury level in the two limbs is 20 centimeter. Okay, then so this is the total maximum height of this mercury. Okay, as we know that the mercury will be pushed by this liquid which is flowing in the pipe, and the right limb and left limb both are containing of this mercury, but the difference of right limb and left limb mercury level is that is given. Suppose let's draw this line. Let's draw this line. Okay, suppose this is the line is there and this is the datum line is there. So this height is actually, this height is 20 mm. That means this is the difference of right limb and left limb, the mercury height from here to here, there is a difference. Okay, so we can say if this is the height is 12 centimeter from here to here, we can identify how much distance from here to here there. Okay, so this distance we can say this liquid is nothing but the normal liquid which is or light liquid, you can say. Okay, now so other data is not given actually, but data supposed to be given for this liquid and like light liquid and the heavy liquid. But anyway, so here heavy liquid is given mercury. So we know that for mercury our specific gravity is 13.6. Okay, so 13.6 means we can identify the density of this, that is nothing but 13,600 kg per meter cube. And here the specific gravity of liquid which is flowing inside that is given already 0.9. So we can calculate the density of this, nothing but multiplication of 1000, and we'll get 900 kg per meter cube. Now we need to find out the pressure at this pipe, at this zone. So we know the formula. We can write the pressure at the right limb equal to pressure at the left limb. So you can write in the left limb, suppose the point you give here a point, okay. So PA plus what is the liquid present here in this distance. So this distance actually nothing but 20 minus 12. So this height will be identified, that is H1. So H1 equal to, we can write rho 1g H1 equal to the pressure at the left limb, that is nothing but rho 2g H2. So easily you can write PA equal to rho 2g H2. Rho 2 is nothing but the heavy liquid density. So that is, you can write 13,600 into 9.81 into H2. H2 is 20 centimeter. Yeah, 20 centimeter H2 is given. So that one we can write 0.2 meter. Let's convert into meter. So 0.2 meter. That is, let's write here H2 equal to 20 centimeter, and that is nothing but 0.2 meter. And similarly, H1 equal to this 20 minus 12, that is nothing but 8 centimeter, or you can write 0.08 meter. Okay. So this is about the rho 2g H2 minus rho 1g H1. So again, rho 1 here 900 into 9.81 into, we can write H1 0.08. Okay. So this will be give you the value, this minus this will get here about 2.597. Okay, 2.59, near about this value will get, and that will be actually Newton per centimeter square, not meter square. We'll get the value actually more in the meter square. So that will be near about 25977 Newton per meter square. That will be converted into centimeter square. We can get this value. So this is the pressure value at this, in this point. Okay. So this is one kind of problem where gas pressure actually. Okay, we have discussed the gas pressure and vacuum pressure. Let one more problem discuss regarding the vacuum pressure types. Similar kind of question given. A simple U2 manometer containing mercury is connected to a pipe which fluid specific gravity 0.8 having a vacuum pressure is flowing. Okay, so similar kind of diagram need to be drawn. So this is the pipe is there, and this is the U-tube step is there, and this is, suppose U-tube is there, one end is open to the atmosphere, and here the liquid which is present inside this pipe. Okay, and let's suppose this is the datum line is there, a point, and the outer end of the manometer is open to the atmosphere. As I told you, this is open to the atmosphere here. So but the pressure will be impacted here, okay, because it is a vacuum pressure case. Okay, find the vacuum pressure in the pipe. So which pressure, or what is the value of pressure at this pipe, that need to be identified. Suppose this is the B point, so we need to calculate the value of PB. The outer end of the atmosphere, okay, is the difference of mercury level between two limbs. Mercury level difference again given, two limbs is 40 centimeter here given. So for this case again, we need to see what is the difference, between these two levels. Two limbs are 40 centimeter is given. Now that means here also mercury is there, and up to some height of this left limb. So let us draw this mercury level in this area. Okay, and this one we can say this is the height of this, so that is 40 centimeter. This is the height is there, which is 40 centimeter. So that means here H2 given 40 centimeter. H2 given 40 centimeter. Okay, and the height of fluid in the left from the center of the pipe is 15 centimeter below. Okay, so this height actually from the center point, it is 15 centimeter. So this is 15 centimeter. So that is nothing but H1. This is nothing but H1, that is 15 centimeter. That's it. Only two values are given, and one more specific gravity given of this liquid which is flowing inside the pipe. So we know that again rho 1 equal to 0.8 into 1000 standard liquid density will get 800 kg per meter cube. Similarly, rho 2 is nothing but the heavy liquid, which is mercury. So that is 13.6 mercury level. So that is nothing but into 1000 again, you will get 13,600 kg per meter cube. And what are the other things required for this? Yeah, now let's find out what is the pressure value for this B point. So PB is in the left side. So PB plus the pressure at this point, because right side pressure is nothing, is 0 is there. So we need to write all these things in the left side only. So rho 1 G H1 plus rho 2 G H2 equal to 0. So we can write PB equal to minus, already this definition, this formula we got in the previous lecture. You can see that video how to identify this. Rho 2G H2 plus rho 1G H1. So put all the value of this H1, H2, rho 1, rho 2, that is nothing but rho 2 value 13,600 into G 9.81 into H2. H2 is 40 centimeter. That one we can convert into meter. That is 0.4 plus rho 1 800 into 9.81 into this H1, how much? 15 centimeter. That is 0.15 meter. So if you solve this one, finally you will get the value actually. PB equal to we'll get the value 54,000. So 54,000 near about will get 543. 54,000. 54 will be this is Newton per meter square, and this one we can convert into centimeter square. That is nothing but 54.5 5.454 Newton per centimeter square. But this value actually will get in the minus value, negative value, because the question is given here for the vacuum, pressure. Okay. So I hope you understood how to solve this problem related to this CO2 manometer when the condition is given for gauge pressure or vacuum pressure. If you are having any doubt regarding this, you can give a comment on the comment box. Thank you all.